So yeah, you'll get to see what I see now, but it looks the same. Okay, so yesterday we kind of finished talking about how sine, if we just want to know what is sine of theta, we're looking at the y value of that ordered pair, right? Because that was the opposite side. So if I imagine that this is a triangle here that we're creating, then sine of 30, right, is opposite, and that's the side going up and down. Whereas cosine, if I think about that, that is the adjacent side, so that is the x value going across. And then tangent would be opposite over adjacent, so y over x. And so that's how we are kind of finding these answers here. So if I want to find the exact value of each trig function, so that phrase exact value, you're not going to give me the decimal. If it says like find the decimal value, you'll type it in. But what we want to do now is use our unit circle here to help me answer this. So if I want to find sine of 45, well then I'm going to go to that 45-degree angle, and I know last class, in the other class, we did end up filling these in, so I'll leave this up at the end of class once I record. So if you want to kind of start filling it in, I know that we only did the ordered pairs and not this stuff in here, so I'll maybe like leave it if you just want to kind of fill in the top half right now as I go back and forth. So 45 degrees, we're locating that is this ordered pair, and sine is the y value, so your answer would be the y value of that ordered pair of root 2 over 2, okay? But I, again, would have that memorized. Sine 45 is very common. I would memorize that one. I would memorize your 45, your 30, and your 60s. Okay, what about cosine of 150? So then I'm going to go to the 150-degree line, which is this one right here. And cosine is the x value, so I'm locating, this is the x value of that ordered pair, so it's negative root 3 over 2. So again, there's not really any work here, it's just can you use this unit circle and know how to read it? Okay, sine of negative 30. So if you have that negative angle and you look at our circle, right, we don't have the negatives. This is why we talked about something being coterminal. You're limited to these angles, so we can either... we'll need to add 360, right? If I subtract 360, I still have another negative angle. So if I add 360 to this, that will tell me what its coterminal positive angle is, and that will appear on my chart. So we can say this is coterminal with 330. So this is the same thing as sine of 330 degrees, okay? They're the same location. We did a full 360. We're back to the same spot. So then I can go to where's 330, so that's this line right here. And it says sine, so I'm looking at the y value. So the y value is negative 1/2. So that would be my answer. Okay. Sine 3 pi over 4. So we can do the same thing if I'm in radians, which is why we want to know both the radian form and the degree form. So I can locate where is 3 pi over 4. That one may take a little bit of looking, but that one's this one right here, which is also the same thing as your 135-degree angle. And since we're doing sine, I want the y value, so root 2 over 2. Okay? So then we have cosine 7 pi over 4 minus pi over 2. This is not fully simplified. We can simplify this. So we want to subtract here. I cannot subtract these fractions yet because they do not have a common denominator. And I recommend, I wouldn't type it, I mean, you can type in like 7/4 minus 1/2, that's fine. But we can easily do this in our head. So this is really 7 pi over 4 minus, that's 2 pi over 4, right? If I want to have the same denominator. 1/2 is the same thing as 2/4. So now I can subtract across here. 7 pi and 2 pi, think of that as, that pi is like an x, right? 7x minus 2x would be 5x. So this would be 5 pi over 4 is really what we're trying to figure out. Cosine of 5 pi over 4. Okay, so then we can locate that one. So 5 pi over 4 is right here. That is 225 degrees. Cosine, we're looking at the x value, so negative root 2 over 2. Okay, and then tangent 300. So we can, well, remember tangent is y over x. So you will do a little bit of dividing there. So if I locate 300 degrees, that's this line right here. So I need to put the y value, negative root 3 over 2. And I'm going to write it like this, negative root 3 over 2 divided by, I'm going to kind of not stack them on top of each other because I know I'm dividing fractions here, divided by the x value of that ordered pair, which is 1/2. And so to me, it's the same thing as writing negative root 3 over 2 over 1/2. But that's a fraction over a fraction, so I'm going to write it like this. If we remember anything about dividing fractions, it's the same thing as multiplying by the reciprocal. So this is really the same thing as negative root 3 over 2 times, flip that fraction over, times 2 over 1. Your 2's will cancel. You have a 2 on the top and the bottom. So we're just left with negative root 3. So I will say this unit, you will want to make sure you know your fraction rules, as many of our, pretty much all of our trig coordinate planes or coordinate points are fractions. So you will want to know how to manipulate those fractions and do things with the fractions. Again, you'll also want to know your 45's times tables. That'll come in handy. Okay, tangent of 90. Okay, so this one we have tangent of 90 degrees. So again, that's putting the y over the x. So my y value is 1, my x value is 0. I don't have fractions here, so I can just write that. So I have 1 over 0. Can I divide a number by 0? No. So what is my answer to this? What do I say when I have divide by 0? Close, really close. Undefined. Yeah, so above the lamp, that's anything over 0 is undefined. So we do want to remember that we don't have it. So yeah, no answer, but technically the formal way to write that is undefined. So tangent of 90 does not exist. That's something that does not exist, okay? And then tangent of 11 pi over 6. So we're going to 11 pi over 6, which is this line over here, the 330 degree line. So again, I'm going to stack my fractions on top of each other, or just kind of divide them. So we have y, so that's negative 1/2, divided by root 3 over 2. So I can write that. So we have negative 1/2 divided by root 3 over 2. But I can use my fraction rules here. That's really the same thing as multiplying by the reciprocal. And so when I do that, my 2's will cancel. I'm left with negative 1 over root 3. But remember, we don't want our answers to look like that, so we need to recall we have to rationalize the denominator here. So I'm going to multiply by root 3. So I have negative 1, or really just negative root 3 on top over 3. And that would be your final answer. Okay? So not really anything too difficult. You're just locating the things, and at the end of class I'll put this back up here so you can finish kind of filling out the degrees and the radians there. Not too bad. Just remember those fraction rules. Make sure you still know how to rationalize the denominator, things like that. Okay, and then I will also post this in color, and I'll give this printed so you have also a very nice kind of clean version, but I think it is helpful to draw it on your own and visualize what's going on there. Okay, so that should help you answer the first part of that homework. Okay, now let's look at, I promise this is not that bad today. We're just extending this to 3 more trig functions, okay? So we know sine, we know cosine, we know tangent. Those are the ones that we've been doing. We're now just going to do the same thing that we did in 11.3 with 3 more trig functions, and we'll talk about what those are. So first, let's draw a little picture here so we know what's going on. So let's just draw our coordinate plane, and we want to make sure we understand how we can find sine, cosine, and theta. So I know we said sine is y, cosine is x, tangent is y over x, but let's also kind of talk about this in terms of my radius, okay? And kind of why we just say y, x, and whatever. Okay, so if we create kind of a line like this, okay, and I'm going to call this the radius. So we can imagine that there's a circle, kind of something like that. It would probably be a lot bigger, right? Okay, let's imagine I have my circle, right? Where in that center, I have any point. This is going to be my radius. That's what I just drew. And then this is going to be the distance y over the distance x, okay? And so we talked about on this last page that we can just say if we're using the unit circle, it's just y for sine. That was because our radius was 1 radian, okay, 1. Now we're going to kind of extend this and say, well, what if I'm going to have a little bit of a different radius? What if I'm going larger? So really, sine is y, right, because we're going opposite, if I draw this triangle again, opposite over the radius or the hypotenuse. So y over r. It's just that r in my unit circle is 1, okay? So if we want to really formalize this, we can say that sine is that y value over the radius, okay? It's just that in 11.3, in that unit circle, it was 1. So y over 1 is just y, okay? So cosine is still x, but x over the radius, really, right? Adjacent over hypotenuse. And then tangent is the same as before, right? We're not even using the radius there, so that's still y over x, okay? But now let's talk about what is cosecant, secant, and cotangent, okay? So cosecant is the inverse or the reciprocal of sine, okay? So these are related to each other. Sine and cosecant are related. So cosecant is going to be the reciprocal, so r over y, okay? We can also see this as 1 over sine, okay? But don't get that confused with the inverse button on your calculator. That's not what that is. So this, I'll make a note. 1 over sine is not the same thing as sine to the negative first power on your calculator. Those are not the same, okay? I wish that someone would have told me that, because all through high school, I was like, wait a minute, like, isn't that what that button is for? Because we kind of know that to the negative first power is kind of like the inverse, or 1 over, but in this case, it's not. That's not what that means in your calculator, okay, right? Because sine is a word, it's not a number that follows the typical math rules, okay? So they're not the same. So then secant is going to be the inverse of cosine, okay? And I remember that because sine and cosecant S and C, and then same with cosine and secant C and S. So the S's don't go together and the C's don't go together. You would think that, they would, but they don't. So it's a little bit different there. So this is r over x. We can say, or that's 1 over cosine. Okay, so the reciprocal there. And then finally, cotangent. That one is easy to remember because it has the word tangent in it. Tangent and cotangent are going to be reciprocal. So this is x over y, or we can say, really, this is cosine over sine. Okay, because tangent is sine over cosine. Okay, so those are 3 more trig functions that we can use, but still kind of following that baseline of sine, cosine, tangent. It's just now that we're going to flip them. So you will also want to keep that in mind of which ones go together. I remember it, cotangent and tangent they use the same word. Sine and cosecant, you want opposite starting letters there. The same letters don't go together. Okay, so if I want to find the exact value of these functions using my new 3 ones here, we're just going to, you'll need to find what sine is and then flip it type of thing. Or, yeah, just think about what is sine, I'm flipping the order there, okay? So for cosecant, again, we want to know, well, what is sine? We can think about this as, there's a couple ways to do it. I'll show you her first way, and then I'll kind of show you how I do it, just so we have different options. But first, if I want to try to find 9 pi over 4 on my unit circle here, so like I said, I will print off this page so that way you have it outside of your notes so you don't have to keep flipping back and forth. So just kind of watch what I'm doing. There is no 9 pi over 4 on here. You can look, that's not what my circle goes up to. So we're at the point where if you start to see some things that are not on your circle, you're going to have to, again, think back to what we did when we had sine of negative 30. That wasn't on the circle. We had to add 360. But since we're talking about it in radians, we need to add or subtract 2 pi, okay? Not 360 degrees, but 2 pi. So that way I can figure out what is coterminal with 9 pi over 4. So I want to, in this case, if I add 2 pi over 4, I'm just going to get another larger number. So I need to bring that down because that fraction is too big. So we're going to subtract 2 pi, okay? But remember, I need to make sure I have the same denominator. So if I subtract 2 pi here, I really need to subtract 8/4, right? 8 over 4 is 2. So really, this is going to be 9 pi over 4 minus 8 pi over 4. That's really 2 pi, okay? So this coterminal angle is really the same thing as pi over 4. If I make that full 2 pi rotation around, I end back at the same thing. That's really pi over 4, which is on my unit circle. So then I figure out, okay, what do we have here? Pi over 4. I want to look at the y value, okay, the y value. Root 2 over 2. So this is how I do it. I like to say, all right, I know that sine of pi over 4 is root 2 over 2. So I'm flipping that for cosecant. Okay, so cosecant pi over 4 is going to be the flipped version of that, 2 over root 2. But again, we don't like to have those in the denominator, so we need to rationalize just to simplify this. So we're going to multiply by root 2 over 2, and so I get 2 root 2 over 2, but then your 2's cancel, so you just really have root 2. Okay? So that's how I do it. Honestly, I feel like I'll probably just stick with that. Because what she's having us do is like write 1 over sine pi over 4, 1 over root 2 over 2. I don't know. I just like to find out what the regular version is and then flip it. That's what I prefer. I feel like that's the easiest option. Okay, so then secant of negative 210. Again, that negative angle is not going to be something that you see on the unit circle. We only have the positive in the unit circle, so we'll definitely need to find out what's coterminal. So I'm going to add 360 degrees, say, okay, if I'm at negative 210, I make that full 360. Where am I at really? What's another coterminal angle? So we have secant of 150. Okay, so secant of 150. Remember, secant is the same thing as cosine, just flipped. Okay, so if I kind of find, well, what is cosine of 150, I can then flip that fraction over to help me figure out what is secant. So if I go to 150, the x value, right, because we're talking about cosine here, is negative root 3 over 2. So that's going to be cosine. Okay, but then secant of 150 is going to be the flipped version of that. So negative 2 over root 3. Again, we need to rationalize here. So there's just a lot of rationalizing in this unit because we're just dealing with a lot of roots. Okay, so when you rationalize there, you get negative 2 root 3 over 3. Okay, and then the last one, cotangent. Cotangent is the same thing as tangent, just flipped. Okay, so I'm going to say here that I want to find, well, what is tangent of 210? So that's whenever I put y over x. Okay, so I'm going to locate 210 on my chart and say, okay, my y value is negative 1/2 over my x, which is negative root 3 over 2. So this is going to look kind of weird when we write it, but we can say the regular version is negative 1/2. This time I am going to kind of write it like this, over negative root 3 over 2, just because I don't need to simplify that one. Then my cotangent of 210 is going to be the flipped version. And so that's really going to be negative root 3 over 2 divided by negative 1/2, okay? Because I am going to end up solving this one. So you may not even need to write that tangent down if you know, okay, cotangent is just, I'm putting the x first now. So x divided by y. So that's why I did negative root 3 over 2 divided by negative 1/2. And so then we can simplify. So this is the same thing as multiplying by the reciprocal. And so when I do that, my negatives cancel, my 2's cancel, and I'm left with just root 3 over 1 or root 3. Nothing to rationalize there. All right, so same thing as what we just did. You're now just doing reciprocals, and you will eventually want to learn those phrases. Okay, there's a couple more things we'll do here. Again, these problems are not bad, but we do want to, again, think about this in terms of that coordinate plane, and what if we don't have that radius of 1? So I want to find the exact values of all 6 trig functions for theta if theta is an angle in standard position and contains this point. So we have kind of a different phrasing going on here. So I need to find all 6 trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, and I only know that I have a point at negative 6, 8. Okay, and so I'm going to, let's draw a little picture here. And we don't need to make tick marks, that's fine. I know that I'm going backwards 6, I'm going up 8, okay? So I'm going backwards 6, up 8, I have a point right here. And so again, we're thinking about this point as like that radius, okay? So we're always kind of centering ourselves at the origin, and so we're imagining that, right, if I kind of complete that circle around here, that we're going back into the center, which is always going to be at the origin, but now we've kind of extended that radius out. It's no longer 1, okay? And so we're going to talk about how can we figure this out here. So we want to recognize, again, that this distance going up is 8 spaces. This distance going backwards is -6. And then, again, I just want to, we're not using the unit circle because the unit circle is only talking about radius of 1 radian. So how we're going to write this is just with the actual like values of your sides, kind of like how we did at the very beginning. And I know it is weird to kind of flip back and forth and differentiate between, but remember back at the beginning here when you were just like writing what is sine, cosine, tangent, you were just saying the distances, right? So that's what we're doing here. We're just kind of doing the ratios, we're doing the distances. So I'll take us back. All right. So if I want to figure out what is this distance, right, I'll need that hypotenuse or that kind of radius in this case. What would that be? You may already know it. This is technically a 3, 4, 5 triangle. If you didn't, I'll quickly show you. We can use the Pythagorean theorem. Okay, but you get 36 plus 64 is r squared, so r squared equals 100, so r is 10. But you may have gotten that it's just a scaled up version of your 3, 4, 5. Okay, so now that we have all of our distances, and I may move this -6 kind of this way, just so we can see. So we're going -6 spaces back, 8 spaces up. That radius / hypotenuse is going to be 10. So if I want to find sine, remember that is just the same thing as your y value over that radius value. So that is just going to be 8 over 10, but we do want to reduce, so that'll be 4/5. So therefore, cosecant, the inverse of that, or the reciprocal of that, is going to be 5/4. So then cosine of theta. So again, we're not using the unit circle because that r value is not going to be 1, okay? So we're just kind of relating the sides in this case. So cosine of theta is going to be your x value. So what was the x value? -6 over r, which is 10. So I can reduce that to -3/5. Therefore, secant is going to be the reciprocal, -5/3. And then finally, tangent is y over x. So we can say 8 over -6, which reduces to -4/3. Therefore, cotangent of theta is going to be -3/4. Okay? So that's really it. The problem makes it seem like it's a lot harder than what it is, but you're just kind of making that point on your order or on your plane, then kind of creating that triangle out of that, and then just setting up your ratios. That's about it. Okay, so there's another one that we'll do. This one is if we're given the actual trig function ourselves. So that was kind of like, again, that first unit or that first lesson where we were given the ratio, we need to find the remaining. It's just that now we're finding those extra 3. So if I know sine of theta is 7 over 9, we can again imagine this, and it says whose terminal side lies in quadrant 2, okay? Because it doesn't actually give me that point value, you may be thinking, well, I can technically put like this way, this way, this way, this way. How do I know? It's telling me that terminal side, remember, which is the side that is getting rotated, is in quadrant 2, which is right here. So I'm going to have something that looks like this, okay? And so remember, sine of theta and that angle is always going to be positioned right here, okay? So sine of theta is going to be opposite. So it tells me the opposites over that radius. So if we want to, or I guess we can say that the y over the radius. So the y value going up is going to be 7 over my radius here is going to be 9, okay? And then I need to figure out, well, what is this side? Well, we'll need to use the Pythagorean theorem, right? Because it doesn't tell me what like the actual angle number is, so I do have to use the Pythagorean theorem here. So we have 7 squared plus, we can say x squared, right? We're trying to find that value of x, equal, or you can use b, it doesn't matter. You can use a, it's just a letter, equals 9 squared. So I get 49 plus x squared equals 81. So x squared, when I subtract those two, gives me 32. And then I get x equals root 32, but we always want to check, can we simplify? Yes, we can. 16 goes into 32 2 times. So we have root 16 times root 2. I know what the square root of 16 is, though. It's 4. So I have 4 root 2 as my answer. Okay, so we can fill that in for this side. Now I have all my sides, and it's just a matter of setting up those ratios. So I already know sine. So if I want to find cosecant, though, because that's the opposite of sine, so we can say we know sine is 7/9, therefore cosecant is going to be the reciprocal, 9/7. Then we can move to cosine. So cosine is going to be that x value over that r value. So the x is 4 root 2 over that r of 9. And then the opposite is secant. And so I flip that fraction. We do have a root in the denominator, though, so let's multiply. I had people do this when we started doing this radical unit. They wanted to multiply by 4 root 2. Don't do that. That's just going to make yourself have a bigger number to reduce later. Just multiply by the root. So when I do that, I get 9 root 2 over, the 4 is still there, the root 2 times root 2 just becomes 2. So this is really 9 root 2 over 8. Okay? Okay, sorry. I forgot the negative here because we're going backwards. So just add a negative in front of your cosecant and your cosine and your secant. Okay, so then tangent is going to be your y over your x. So my y is 7 over my x is negative, because we were moving backwards there, is negative 4 root 2. Again, we have to simplify. So if I multiply by root 2 over 2, I get 7 root 2 over 8 and still negative. So then the opposite of that, cotangent of theta, is going to be that flipped. So negative 4 root 2 over 7. Nothing to rationalize there. Okay, so it's really, again, not a lot of really difficult work, just a lot to memorize, a lot to kind of keep track of. Make sure you know which ones go together. Make sure you're remembering, well, which one's y over r, which one's x over r, things like that. So it will come with time, it'll come with practice. I think we can get this done. I know that this has been a very long lesson today. It will kind of ease up on Monday. We're going to have a review day and practice, so we won't have a lesson Monday. Okay, so let's just do some basic overview of what are going to be kind of my signs whenever we're talking about sine, cosine, tangent, okay? So if we are looking in this first quadrant here, both your y and your x are positive, right? You're going up and you're going to the right. So if we have that ordered pair, you're going to have a positive number for your x and a positive number for your y in your ordered pair. So that's what that little parentheses plus plus is talking about. And so if we want to determine, well, then what would be the signs of my trig ratios here? Well, sine, remember we look at that y value to really dictate what's going on. Well, my y value is positive. Okay, cosine, again, you're looking at that x value to kind of determine what's going on. That would also be positive. Tangent, you're going to stack the y over the x. Well, positive over positive is still something that is positive, okay? And I know that this may seem like a little bit of common sense right here, but then let's move into the second quadrant and talk about what's going on there. So I have a negative, thank you, x value, right? Because we're going backwards. That was just like the problem that we did. So that x value is going to be negative, but we're still moving in that positive y space. We're still on top. So if I want to say, well, what is my sine going to be? What would I have? I would have something positive again, because we're only really looking at the y value for sine there. But this time, cosine, what would you have? You'd have something negative, because you're looking at the x value, and your x value is going to be negative. Tangent is when you stack them on top of each other, y over x. So a positive over a negative number would be a negative number, okay? So this is another way for us to kind of see, based on, like, I may give you, okay, you have sine of theta equals positive 7/9. You can kind of figure out, okay, wait, there's only 2 places that sine is positive. It's got to be in the top half. So it's just going to help us kind of figure out where would my ordered pairs, or where would that, terminal side be. Okay, so then I'll go kind of fast on these next ones. So here in this quadrant 3, you're going to have a negative and a negative, right? You're to the left and you're down. So sine this time would be negative and cosine would be negative. But my tangent is actually going to be positive because a negative stacked over a negative is a positive number. And then finally, that fourth quadrant, we have a positive x because we're moving to the right, but a negative y. So I would say now sine is going to be negative, cosine is going to be positive, and tangent is going to be negative. Okay, so hopefully you can kind of see those patterns. Top half, sine is going to be negative. Bottom half, sine is going to be positive. On the bottom half, it's going to be negative. To the right, cosine is going to be positive. To the left, cosine is going to be negative. So it can just help us kind of visualize where are my points at. Okay, so for this one, it says if cotangent equals 3/4, we want to find all possible values of sine theta and secant theta. Okay, so this is, again, that kind of visualizing that we want to do here. So let's go ahead and figure out where could this be. First of all, it doesn't say tangent, sine, cosine. It says cotangent, which is the inverse of tangent. So I could say that tangent is actually 4/3, right? Which is positive. And it doesn't tell me this time what quadrant it is. So we will want to look and say, well, where's tangent going to be positive and what quadrants? Well, it could be this quadrant or it could be this quadrant, okay? So we can kind of set up my coordinate plane here and we can say, all right, so I know that I'm either going to have a line extending this way or a line extending this way, right? It says it's finding all possible values. It's not specifying, oh, it's in quadrant 1. But we know it's either got to be in quadrant 1 or quadrant 3 based on the positive tangent value there. All right, so again, here's where my theta is going to be. Here's where my theta is going to be. So tangent of that is going to be, if we kind of create our little triangles here, tangent is going to be that opposite over adjacent. So opposite side, that y value is going to be 4 over the x value of 3. And I can go the other way too, right? My x value here is going to be negative 3, and the y value is going to be negative 4, right? So I could have either one. Both of these are going to exist, right? Because I have 4 over 3, that's positive. Negative 4 over negative 3, that's also positive. Both of these would work. So if I now want to find all possible values of sine theta, well, I do need to find the hypotenuse here, but again, this is a 3, 4, 5 triangle, so we're going to say that this is going to be 5. All right, so I can say that sine of theta here could either be, 4/5, 4, because opposite, or the y over that radius, so 4/5, or it could be, if we look the other direction, negative 4/5. Okay, so really you'll kind of learn as we do more of these and as you do the homework, it's really just different signs. Okay, the values aren't going to change, but one's going to be the positive, one's going to be the negative. That's what you'll kind of learn about these problems. If I want to know secant, okay, secant of theta, remember, is going to be the opposite of cosine. So we maybe want to make a note there, opposite of cosine. So if cosine is going to be that adjacent over hypotenuse, or we can think about it on the coordinate plane in terms of the x over that radius hypotenuse value, then secant is going to be the flipped version of that, the radius over my x. So the first secant that we can do is that radius 5 over the x 3. So 5/3, and then we can also go the other way. So I can also have secant theta being negative, or that positive 5 over negative 3. So negative 5/3. Okay, so that's about kind of as difficult as it's going to get with those. Okay, I do definitely recommend drawing that picture out, looking at this chart when it doesn't tell you what quadrant that terminal side is going to lie on, because that's really going to help you figure out what quadrant am I in. Okay.